Alright folks, chapter 1 again is a refreshing of all the concepts you learned in Algebra 1. So this section hopefully you guys are all very familiar with. It's something that you've used extensively in Algebra 1. So I'm going to try to shoot through this a little bit quicker. And we're not going to read all the objectives to you. You guys can read them for yourselves. Let's go ahead and jump into the lesson. So the first thing we're going to do is convert words into expressions or equations. Here we have degrees Kelvin equals 273 plus degrees Celsius. If I wanted to write that as an expression or an equation instead of in words, the first thing I need to do is define some variables. Sometimes they give them to us, this time they did not. So we'll say, let's use big K equals degrees Kelvin. Here's big K. And the other thing we need to do is have a degrees Celsius. So we'll say big C equals degrees Celsius. We'll call that one big C. Now one technique is to write over the top of the words. We have an equals here, degrees Kelvin, big K, equals, it gives us a constant, 273, plus means adding, addition, plus C. Now I can rewrite my expression underneath it. K equals 273 plus C. That's as simple as it is, folks. All you do is you read the words and you interpret them into an expression or equation. Now we get a little tricky sometimes. Here the variables are given to us. We don't need to define them. They don't have any meaning beyond just the variables because we don't have any meaning to assign to them. But we are told that the sum, so here's some key words. Sum means addition, so we're going to have a plus out there, of 5 times h, so we've got a product as well, 5h, and twice g, or 2g. You know what, I'll go ahead and we'll change this color over to green. So the sum of 5 times h and twice g is equal to 23. Now the little trick of writing over the top of the letters here, you got to be careful with, because it read it to us a little bit differently. Here the plus 5h2g doesn't really make much sense to us, but if we read what it says, the sum of indicates that I'm adding two numbers, and those two values are 5h and 2g. So 5h plus 2g is equal to 23. And then we're complete, folks. Let's do another one. This one you guys should remember from geometry, should be familiar to you. The sum S of the measures of the angles of a polygon is equal to, so S is the measures of the angles of a polygon, and S equals, that's equals 180, there's my constant, times the difference of the number of sides in and 2. So it's defining the variables for me as we go, so we don't have to write a key out for us. But it equals 180 times the difference of the number of sides in and 2. Well, the difference of the number of sides in and 2 is just n minus 2. Anytime we see difference, we always do the first in, and then the and then 2 tells us the order we're doing our subtraction in. And we want the product, or 180 times that difference. So S equals 180 times n minus 2. And again, this is a formula you should have had in geometry, you should be familiar with. Now let's look at Lucy's age, Y years after her birthday. It doesn't give us a variable for Lucy's age, let's make it L. And I'll change my color again, I'll go black this time. L for Lucy's age. And we know that L equals, we want to know Y years after her 18th birthday. So when she's 18, we want to go Y years beyond that. 18 plus Y. So 3 years after she's 21. 18 plus 3 is 21. There we go. So be able to convert these words into expressions and equations and that will help you out greatly when we get into harder word problems later on, okay? All right, let's talk about simplifying expression. Here's a process you guys should all be familiar with. I'm not going to go into great detail here. I'll work through a couple problems. We're going to use PEMDAS, and we're going to combine only like terms. So on this problem, the first thing we need to do is simplify the parentheses. We're going to evaluate parentheses first. Here we've got 2x minus xy plus 3y minus x. My only like terms in the parentheses here, the only thing we can do is combine the negative x and the 2x. Everything else stays the same. 2x and negative x make it x, and minus xy plus 3y. And then we're going to subtract 11xy. Nothing else changes. I don't have any exponents, so I can move on to multiply, divide. Now remember, when we're doing multiplication and division, we're going to go left to right across the problem. We don't multiply first and then divide first. We simply go left to right, doing all the multiplication and division in the order that it appears. So in this case, the first multiplication we have is a form of distribution. We're going to distribute that 3 onto every element. But we're not just distributing the 3. Remember, there's a negative with it. So we need to distribute the negative 3. Negative 3x. And negative 3 times negative xy is positive 3xy. Negative 3 times a positive 3y, that's a parentheses right there, is negative 9y. And then we still have our minus 11xy. Now you could keep your parentheses here if you wanted to, but it's not going to change any of the processes now because we just have subtraction left. So now that I have all of my terms written out in one line, no more multiplication or division, I do addition, subtraction. And again, I'm going to go left to right in the order of addition and subtraction. Or a better way to look at it is, instead of thinking about subtracting 11xy, think of it as you have negative 3x, you have a positive 3xy, a negative y, and a negative 11xy. And all we're doing is combining everything together. I've got negative 3x. Forgot my y here. I've got a negative 3x and no other like terms. So I'm going to leave it as negative 3x. I have 3xy and I have negative 11xy. Those will combine. They are like terms. What do I get when I combine 3xy and negative 11xy? I get negative 8xy. And then my last number is negative 9y. Here is the simplified form of this expression. Now let's look over here at our next problem. I'm going to distribute my j in. So first I have parentheses. I can't combine anything in this parentheses though. So I move on to exponents. I do have exponents, but there's nothing I can do to simplify k squared. It's as simple as it gets. So I go ahead and distribute my j in. I get 6 jk squared plus 7 jk. On the outside I have plus 9 jk squared minus 7 jk. And my next steps, all I'm going to do is start to combine like terms. Many operations, many ways to do this. Some people will box them, some people will square them, some people use different colors. I'll use different colors. I have jk squared here, and I have jk squared here. I have jk here, and I have jk here. What we have to be careful of is to make sure that we include the negatives with our terms when we do this, so that we don't get the wrong answer. I've got a positive 6 jk squared, a positive 9 jk squared. That combines to a 15 jk squared. And here I have a positive 7 jk and a negative 7 jk. When I add those two together, I get 0. So my simplified answer is simply 15 jk squared. All right, that's simplifying expressions, folks. You have a lot of problems you could practice. And we'll work through any questions that you have in class on it. But hopefully you guys are all familiar with this. Now let's work on evaluating algebraic expressions. All we're doing here is plugging values in. We're giving values for the variables and we plug them in. The key to plugging variables in, ladies and gentlemen, is don't do anything the first time through. All you're going to do is take your variables away and write parentheses. All right? I'll use blue for x's and I'll use green for y's. So I have something squared times something. That used to be an x, that used to be a y. I'm going to plug something in for it now, but I'm not going to do it yet. Minus an x variable times a y variable squared plus 3 times a y variable. Now I do this for a reason. It's kind of simplistic and it seems kind of ridiculous, but now when I plug everything in, the negatives will stay where they need to stay at. So when I plug in -2, everywhere there's an x, and I plug in a 5, everywhere there's a y, I'm not going to lose or mess up this negative. I'm not going to have this negative on the outside and inadvertently have -4 instead of +4. So my next level would be 4 times 5. This negative times a negative will become a positive, plus 2 times 25 plus 15. And down one more level, I'm going to get 20 plus 50 plus 15. My final answer is 70/85. That is what that expression equals when x is -2 and y is 5. Now I know it looks like a lot of steps. I'm showing every little bit of work, and it's important that you guys show all of your work as well. If you're working this problem and you get confused, I can't give you partial credit if you're skipping steps. If you drop a negative, everybody drops a negative sometimes. It happens. But if you show all your work, I can see where the mistake was, and I could probably give you partial credit. All right, over here, we're going to follow the same process. All right, we're going to plug in -3 for all the r's. We're going to plug in 7 for all the q's. So we're going to do -3 for all the r's and a 7 for all the q's. I'm going to have something squared plus 4 times something times something, which is r. And I keep saying something because I don't want to plug it into the very end. Minus something squared. Everywhere there's green, I'm going to put in a -3. Everywhere there's blue, I'm going to plug in a 7. And now I'm simply going to follow the order of operations to simplify. Parentheses first, I get 49. And this we can evaluate. 4 times 7 times -3. We'll just do 1 to start with. 28 times -3 minus, inside this parentheses, I'm squaring it. So we got parentheses exponents. I'm going to square this guy. And I'm going to get a +9. Now here's where the negatives really come into play heavy. I've got a -3 squared. The -3 squared is +9, but that negative on the outside is still going to apply. So my next step is 49 plus, what's 28 times -3? That's going to be 60, 84, and it's going to be negative. So plus a -84 minus 9. So let's go ahead and start to combine these. I like to find the easiest way to combine things. Now I know that I've got 49, -84, and -9. 49 and -80 and -9 I'll do first. That makes 40. And 40 and -84 is negative 44. Folks, now I realize that a lot of this stuff you've already seen before, and the videos are they're kind of dry right now. But I promise that when we get moving on, we're going to get into some higher level thinking, and we're going to start working out some new processes. Chapter 1's a little bit of review, so just kind of settle in. And if you understand the concepts, if you understand the work, just knock it out and take it as an easy grade. But make sure you delve in and you're asking questions in class and you're working through all the problems so that you're not convincing yourself you know something and you don't all the way know it, and you're making simple errors that are going to come back to bite you. All right? We'll see you in class. Make sure you come in with your questions.